Hello, Internet.
Hello,
I'm Eric Seidel,
I'm Adam Barth. Welcome to Rubber Duck Engineering.
and this is episode 3 where we continue our adventures in wave parsing.
If I remember
You want
correctly, we had just finished parsing the metadata out of the wave file, and now we're ready to actually get to the actual wave data.
Do you want to remind our beautiful viewers what we were actually doing when this whole adventure started? Why we're in a wave file?
Yes. Okay. So we're our goal is to visualize some sound. So we want to do one of those cool graphic equalizer things, or maybe some kind of awesome animation based on that. And then we decided that in order to do that, we had to be able to read in some sound file. So we downloaded a freely licensed sound file off the internet, discovered that it was in WAV format, and started reading the docs about how do you parse WAV format. And we've managed to parse out all the metadata so that we know that we have 2 channels of sound. We printed out a bunch of numbers else about it. I don't remember what they were.
We can pull up the code at this point. Oops. I gotta share my screen. There we go. That's our format. And this is our code. This is where we left off last time.
Oh, that's right. We totally have 8,000 as our sample rate. 8,000 what? Nobody knows.
I think it says in the spec, but yeah, so we managed to parse. So we're using a language called Dart, and we looked around for some various sound, and there were sound libraries and stuff. We just decided to write our own. So we're writing our own to parse wave, and we're 3 episodes deep in this. But we got the top of the file done. We got sort of the format chunk, and now we're into the meat and potatoes, the sound chunks, and we just gotta roll them out. So what's next on our list?
Should we look at the spec and see how the data is actually formatted?
Yeah, so let's see. We've read this part, the purple part. You can see my mouse. We've read the green part, and now we need to read a bunch, or maybe there's just one data subchunk. We need to read the data subchunk, and then we can actually handle the data.
Okay, so it looks like there's actually 2 more 4-byte pieces of metadata, which is the data ID and then the size.
And there's number of samples. So each of the data comes in chunks of samples. Still not sure what this is going to look like.
Number of samples, number of channels. Oh, there's a diagram down here. Data chunk. Oh, look at this. Okay, so that last row, I think, is going to show us the actual data. So it looks like there's 4 bytes for sample 1, sample 2. I see. So it looks like every other...
Right. Well, I think we have to look at this format. Audio format PCM, 2 channels. That's like what we have.
Yeah.
Subchunk size. Let's see what the subchunk size for us is. We have it here. Subchunk size 16. Okay.
Mm-hmm. We had PCM. Yeah, that was right.
We have a slightly different sample rate.
Mm-hmm.
Block align, bits per sample.
Right.
So, so this is key.
16 bits per sample.
Yeah, so that's why these are each.
Oh, I got it. Okay. So each sample is the first 16 bits are the left channel, and the second 16 bits are the right channel. That's what this diagram is trying to tell us.
Are you sure?
I think so. Because it looks sample 1, it has a little bracket and it has 2 circles on each of the 16 bit chunks.
Oh, yes.
Mm-hmm.
Bits per sample. Oh, I see. Okay. It probably says this in the text too.
Oh yeah, we could read, huh? General discussion of written files. I think we just try it.
How bad can it be?
How bad can it be?
Okay, so in our wave format here, we Oh, by the way, internet, we did fix our collaborative editing. So,
Oh, can I try typing?
oh, please.
Okay, I'm totally gonna do the data chunk thing. Is it working?
Yeah, I see it working.
Oops, I totally messed it up. Data chunk. Oh man, I feel like I'm part of the stream. Read the chunk header. Okay, so I think we need like more like chunk ID.
Because if I look back at there is a chunk header for this data subchunk, right? There's the ID and size.
I'm just spamming them to the file right now. Data chunk.id subchunk to size data chunk.size. I did it.
Oh. It hasn't quite loaded in yet, but it's coming.
Oh, I typed it all. This live editing thing is a little bit of a dream.
It's making its way through the tubes.
Okay,
it's coming.
It got to you.
They were just a little clogged. Okay.
Maybe you should type now.
Okay. Yeah, the tubes are much more direct from my keyboard to the the file. Okay, so we've successfully parsed those out.
Actually, I wonder. So we're still in the constructor, right?
We are still in the constructor, which is totally wrong.
So maybe we should just stop, and maybe we should like make a new function that's like, get me the next samples or something.
Yeah, because these can come in multiple subchunks, right? Yeah. So like if we do.
Well, you don't want to read the file is like a megabyte big, right? You're not going to want to read it all at once. You're going to want to like grab some samples, work with them, grab some next samples.
So like read next sample chunk? Is that what you're thinking?
No, it's not a whole chunk. So I think there's one chunk that's the whole file. You're going to now just going to like read a bunch of samples. I think you want to read it into like one of these type data arrays. So like you want to pass in, I guess, a uint 16.
Why don't we see how big this one is, just in case it?
Yeah, that's a really good idea.
Did you add? Oh, you did. Okay, so we're gonna end up changing this.
That's okay.
Because this doesn't probably belong there. But let's just make sure.
So I'm guessing, I'm gonna place my bet. My bet is that if you add up the size or whatever, you print it out, it's gonna end up being the total size of the file.
That is just one chunk.
Yeah.
Okay. So this should be subchunk 2. It'd be a very simple file format.
we may have over-entered the parser slightly.
Just a little bit. Okay, I think I saved it. Saving. It's running the Dart formatter, and I think getting sad about it. I may have to kill all Dart. Okay, the Dart formatter appears to have gone out to lunch. This computer was slept multiple times and did other things that were not this. All right, let's restart the analyzer. Yes, I killed all the Dart things. Please restart them. Oh man.
There are a lot of Dart things.
Okay.
It's mad.
You know what, internet? We're gonna close our editor.
I feel like this podcast is like 85% engineering, 15% restarting Visual Code.
I mean, I will have to admit, as someone with 20 years of engineering experience, I will tell you that possibly 15% of your time you are restarting your compiler or editor or whatever piece of technology is broken that day. Okay.
Well, it saved, so that was good. Like
we did it. We did it, internet. Okay. Now we have to run this thing, which is dart lib wave.
Yeah.
Subchunk ID.
Right. So compare the Oh, subject ID curly bracket. That must be a typo in your print statement, I'm guessing.
Well, it's not clear that it is.
That's super weird.
What is the subject ID supposed to be?
It's supposed to be data. DATA. That's so funny because the whole rest of the file parsed so beautifully.
Well, it's very possible that our skip to the end of the next chunk is busted, or that the format lies.
Do you want? We could look at the file in like a hex editor. Because we should just be able to see data in the hex.
All right, let me pull up a hex editor. Hex fiend. I don't need to install an update, even though I haven't updated you in 18 years. Okay, let's open a file.
So we're still looking at the.
Yep, it's coming.
Okay.
It's coming. There's just only so many. Let's see, we're in. Sorry, Internet. I don't really want to show you my entire drive. Nothing personal.
I did see briefly the size when it flashed up on the screen, and the size looked very reasonable. It seemed very similar to the total size for the riff chunk.
Okay, so theoretically, okay.
This is an eye test.
Can I make it bigger? Font, size. There you go.
Okay.
Except.
Oh, look. So it says data there, and there's totally a curly brace before.
Before.
Huh.
So that makes me think that there's something funky in our.
Like we're off somehow. Interesting.
Yeah, there's this extra junk here.
Maybe there's like an extra chunk and we need to skip over it somehow.
Well, it talked about this extra byte.
Can you look at the hex file for a second? So I'm trying to read. So after the format chunk, after where it says FMT, sorry, I'm pointing at my screen, which is totally useless on the file, on the video. I was just wondering if we could read the number that comes after that, and then try to see whether.
Which, I'm sorry, the number after FMT.
Yeah. So it's FMT space, and then that number is like suspiciously round.
Let's just see what the format says. Okay, and then this is sub chunk size. So it's 4, and saying that's 16.
Oh, I see what's going on. Yeah.
So there's these 4, and then there's 2, which is 0, presumably. Oh no, hold on. These are hex, right? So each one is
right. So it is a round number in hex, right? Because it's 16 or something.
Okay, so hold on. Format is okay. So that's 4 bytes. This is another 4 bytes. Here's our 2 bytes.
Right.
Yep. Okay. And then after that.
So when you printed it out, can you look at the output from the when you printed out how we parse the fields?
Did we do byte write and block align? I'm sorry, the output from when we parse the fields.
So we decided the size chunk was 16, which is why it looks like such a round number. So I'm just wondering if you count 16 bytes from the beginning of the format chunk in the hex editor, where does that put you in the file?
Oh, you know what? I wonder if it includes the little, does it include the ID and the size? Does that include in the header? I bet it doesn't.
I bet you're right.
So
that's a really good point.
The seek to after plus header size, something like that. I don't know where that goes. It's like const.
Well, another possibility is when you're recording in read chunk header, you could read the offset after you read out the chunk ID and the size.
I think that'll be confusing, though.
Okay, that's fair.
So okay, that may be the wrong cheat that I just did.
Oh, well, there you go.
This now looks better.
That looks a lot better. Yeah, so if you compare the chunk 2 size to the overall chunk size at the beginning.
Yeah, we're very close. Like this looks like the whole header.
Yeah.
We could ask it exactly how many bytes. I'm asking the Google to do the math for me.
Google's my favorite calculator too. How many teaspoons are in a gallon? Like,
it says we have 262 bytes.
Different?
Yeah. It feels like there might be something right at the end there.
That's interesting.
We can just see what it is.
Yeah, I'd be really interested.
We'll see if we crash, I guess, kind of.
I don't think we'll crash. We're like seeking around. Mystery chunk.
Like, I feel like I should just print it. I mean, I could also just jump to that index. Whatever, okay. I think we're a little off track.
Okay.
Maybe we should just ignore the mystery chunk for now.
Okay. Do you want to make a comment that we think that there's a mystery chunk, and then we can, at least in our example file. I also don't know how representative our example file is of WAV files. It was literally the first WAV file I found that A, was liberally licensed, and B, did not sound offensive when I listened to it. I didn't actually find any offensive ones, but that was one of the criteria.
I did wonder how many got excluded in that criteria. Okay, so talk to me about, I think we should read some data, right? Like, yes, we're not in the right.
Yeah, so
we could and maybe should refactor some, but
yeah,
you're saying.
So maybe now this may be a premature optimization, but I'm kind of imagining that the client wants to supply the buffer to this class and have this class fill in the data from the file and then like return how many it gave you. And that way, as you're like churning through the file, you can reuse the buffer over and over again.
Yeah, I could imagine that, because you're only going to process some fixed number of look ahead samples or whatever at a time.
Yeah, I think we're going to pick some window size, and then we're going to run the fast Fourier transform on it, and so the caller can decide how many it wants at a time, and that'll give us flexibility later.
So, okay, so you want like a fill window, and we pass a byte array or something?
I think.
What are you thinking?
I was thinking int 16 list.
No. Maybe these aren't the right names, but
yeah. I mean, I think when you do like real audio stuff, you have all these like different formats you're supporting and all these things. But I think we're just gonna like hard code it down to whatever our example file has.
Are you suggesting that we are not real audio engineers, Adam?
No, whenever I write code, I try to imagine like what is the real ultimate version of this code going to be like, and I know I'm not going to type that, but like I try to have it in mind so that I have it in mind because I think that someone later is going to come by and get it closer to the real ultimate code, and I want to make sure I'm not leaving them in some dead end that's going to work out badly. And
yeah,
I don't know how effective that is. It's probably totally ineffective, but it makes me feel good when I'm typing the code.
My guess that this specific piece of code is unlikely to end up as the canonical WAV parser, even for the Dart universe.
Okay. I'll accept that.
Which would suggest that we could just grab out the entire data chunk and then like window through it outside of this code and just move on with our lives.
That's true, but I actually think this will be easier because I think when we're working with the fast Fourier transform, we're going to be doing it in a window anyway.
Okay, so maybe we should write that code. Maybe we should write some of the FFT code, or find an FFT guard, and then decide from that what sort of API we need to feed it from the file.
We could do that. I mean, I was hoping to sort of just draw the waveform graphically, because we're going to want to do like a graphical part of this anyway. Just to...
Okay, so do you want like, what do you want? Read samples, and then like we could have like a sample class. Sure. And then you want like a number of them? I mean, we could have a non-copying. I think we can just have a copying. Like, this is really tiny data here.
I'm just going to put the int16 like list and not worry about any of this.
Maybe you want to type?
Oh, sure. Okay. Well, because you restarted, I lost the connection. You have to.
Oh, sorry. I'm failing to understand your vision here.
It's going to be like literally one line of code. So if you
make it so. It is inviting you.
I think you have to send me the link, and you may not want to show the internet the code for the link.
That's okay. It is smart about that. Okay, you have been invited.
Okay.
And I have copied the collaboration link, and I'm sending it to you again, just in case it's changed. Okay. It has changed, so
yeah, I think it changed.
There you go.
All right, I'll try to do this.
I do wonder what that mystery chunk might be.
All right, I'm totally in the file. Okay, read samples. Yeah, I was imagining like int int16 list samples, and then calling is the file exposed? No, we decided not to expose the file.
That's in the parser, I think. Oh, you're reading just a sample?
Oh, you do the whole thing all at once.
Oh, I see. This is telling you how many you read.
Yep.
So you're trying to make a non-copying version, basically, where you pass an empty uint list and fill it?
Yes. Oh, wow. This is...
Feels like we're C programming here.
Well, there's a... what I'm getting at eventually is in bytes, they have read into sync, which does exactly this.
Okay.
I think this may not be exactly right for the number of bytes, because this is working in bytes. So I need to like get this viewed as bytes. Sample dot buffer dot.
And do you know if you're getting back a mutable?
Yes, I think so.
Like another way to do this is just to read out sample structures of some form.
Byte buffer as uint8 list. And then I want to divide by 2. Tell me the number of bytes, and I want to return the number of samples.
Well, this is assuming that that's the samples can be different size.
That's true.
Right, it just so happens that the sample size.
I think we're making the assumption we're dealing with 16 16-bit samples here.
So we want to like assert that down in our like our what was it, our sample bits per sample.
Yeah, so we want to assert the bits per sample.
I'm typing it. We're probably confusing the viewers by typing in 2 places at once. Okay.
I'm not sure what's going on in line 65. It's mad about my division. I took an integer and divided it by an integer, and it told me that I was.
One of them it thinks I think is a double. Double cannot be returned from method read into.
Is it like squiggle divide? Oh yeah, squiggle divide. That's totally it.
But why should you need to squiggle divide?
So read into sync is telling me the number of bytes that I read, and I wanted to return the number of samples that I read.
I see. It's that it's up converting this to a double and then treating it as a double divide. Like, it just seems odd to me that we need to squiggle divide here.
I was just thinking Dart, the slash is just a thing that returns a double.
I see. Okay. Okay, so shall we try and use your fanciness?
Yeah.
So I think we have a main function in here somewhere. Yep, up at the top, there's this main function. So you want to take your WAV and then you want read.
Yeah. So we need to create a buffer to put this in.
Yeah, I'll let you type.
Okay. Oh, so when you scroll down, it actually scrolls my screen too.
What?
I know.
I love it. Really? When I scroll down, it scrolls your screen. That's wild.
Well, what happens is your cursor is active, and so it pulls me to see your cursor.
Oh, fascinating.
Okay, well, let's take 8 samples. We first should check that we're actually reading as many samples as we expected. And then should we print out?
I'll go. Are we ready to run? Let's see. Undefined name parser. We still have a. We're not going to be able to run yet.
Oops. Oh, sorry.
That was me. I moved you. There we go. I moved you back.
Okay. I think the parser thing is we created the parser as a local in the constructor. We didn't save it, which means we lost. We lost access to the file outside of the constructor.
I love your for loop here.
I don't know like any cool vertical editing tricks.
Well, why not just a for loop? Whatever, it doesn't matter. Let's go.
I ran the for loop in my brain, man.
You gonna scroll it, or are you able to scroll?
Yeah.
I'm gonna go down to parser. Yeah. Read samples.
I think we just need to make parser like a member variable of the class.
Otherwise, we're not going to remember where we are.
Right.
All right, fine. Easy to do. It really should be like the first one. Okay. Using braces to avoid interpolation. Yeah, fine. Okay. Let's see. Did we crash? Okay. Those look very suspicious. This is like a negative number, right?
Well, why don't we compare it with the hex editor and see what we think?
Okay. So our hex editor, we got to go to our data section.
Okay.
And then after data, there's, remind me.
It says data, then the next 4 bytes are the length, and then the next 4 bytes should be the first sample.
The size. No, it's, oh, I see, you're right. So it's data, and then this is the first sample.
Well, half of that, right? Yeah, so that, yeah, so what is that number in decimal?
This thing has that ability to like show me.
The Google can do it too.
The Google? Really? Yes, no, I believe you. Just being incredulous.
I do this all the time with colors, because on Mac, the digital color sample thing, which is lets you point at a color on the screen, reads out in decimal, but then I'm often drawing in like Google Slides or whatever, which takes input in hex, and so I have to convert using Google search.
Okay, 36607. Is that what we were? No.
Something
36607.
Okay, something's wrong. Oh, it's little endian. Did you convert it to little endian? You got to do the byte swap. Oh, maybe we're not. Maybe we messed that up.
Well, I don't believe that I necessarily. Was I supposed to byte swap? So I'm sorry. The byte swap would mean it would be FF.
Yeah.
8E.
Yeah.
Okay. The Google didn't do this, by the way. It's taking me to like random websites. FF8E according to decimal-to-binary.com.
We're not sponsored by decimal-to-binary.com.
We are definitely not sponsored by decimal-to-binary. It's also not secure and didn't seem to change when I changed the number.
Don't type in a secret hexadecimal number.
Oh, you know what? The rest of the internet could also be enjoying our usage of Google here. FF8E as decimal. Let's do this. Number rocks.
Number rocks.
Oh, good.
Why do these sites not have certificates? No, I think if you say FF8E hex. Oh, this is good. Yeah. Okay.
65422. We found our winner. We can ask them to sponsor us next time. There we go. Okay, so if we little endian byte swap.
Right. So,
Is that what we want? Let's go back to our.
Oh yeah, this will tell us. Oh no, it didn't tell us what the samples actually were. Oh, you know what I bet it is? I bet they're signed. I bet 0 is silence, and these are small negative numbers, not huge positive numbers.
Mm-hmm. That makes more sense. Let's see.
Okay, so let's.
8-bit sample data are stored as unsigned bytes, ranging from 0 to 255. 16-bit samples are stored as 2's complement signed integers. Yes?
So they're signed.
Okay.
Okay, so I've converted it now to signed, if you want to try running it again.
Okay.
Oh, I didn't actually change all of the places I needed to change. I got one more to change.
Okay.
Great, try it now.
Okay.
That looks more legit.
Especially since these can get way bigger than that. So we're bobbling around 0, which is silence. We're guessing.
I think in the beginning they're getting ready to strum their guitar, you know. This little bit like hum from their amplifiers.
I haven't actually heard this I haven't heard this one, and I don't know if my sound comes through.
That'll be the payoff at the end of the podcast. You'll finally hear the sound.
Okay, so what are we gonna do with this?
I mean, I think we should try to draw it as just a wave. Like, I don't know.
So we want like a rolling.
Well, I would just do one. I would just take let's take 100 samples and just like plot them and see them on screen.
All right, so we're gonna get graphical. Is that what I'm hearing you say?
Yes, that's good. We entered Tron. We're ready. We're ready to go to graphical.
We're leaving the command line. Okay. So that means we need to go to the Flutter side of the project. And okay, so this is going to be new for the internet because we created this Flutter project, but we haven't actually used it. Are we running it? Looks like we're set up to run on Mac. Let's try it. Let's see if it works.
This is when we launched the Great Old Missile last time.
Or 2 times ago, I think. And then we gave up because it started downloading the internet.
Oh, it says Mac.
To get a little bit of Java.
It
says Mac. Yeah, no, it's down here. It's and it's launching, which means it's building an Xcode for the first time. Oh, I see. It also says Mac here. Yeah. I've been using the Flutter desktop environment actually to program quite a bit recently. So I really enjoy. What?
I was going to ask, what should we expect to see? Are we going to see like some beautiful material design thing, or?
We're going to see the basic Flutter example because we haven't changed any of the code. We can go look at the code actually while it's thinking about what it's doing. This guy, in fact, we can close. If I can figure out how to close this one. Split screen here. So I haven't removed any of the comments, but it's a pretty straightforward. It just shows a counter, and there's a little button you can press to increment the counter.
I see.
It looks like a little mobile app, or it's going to look like a little mobile app, except in a big Mac window. We can see.
Go ahead. It's running like behind your window or something.
No, I think it's still building. If I recall correctly, it takes a little while to build the very first time in Xcode.
What do we want to?
We can also build it on the command line and see it more.
Oh, if we want to just like start speculatively like hacking on the graphical part of the code, or
sure,
going to mess it up while it's going.
No, it's not going to hurt it at all. Here we go. A little surprised it didn't show anything. Okay, here it is. So we have a little counter. That's the only time we have to do that. We can now just do everything in Dart.
Okay, cool.
We do have to add a dependency, so that's going to take us a little while. So we can remove some of these comments. But you said you wanted to like. So is this over time, or you just want to show these? I was just
gonna, the simplest thing. Like I don't know, we get like a canvas and just grab a bunch of samples and just draw them.
Okay. So, okay. How do you want to do that?
We can make a widget. Isn't that the answer in Flutter? Everything's a widget.
Everything is a widget. Oh, I see. It's still starting all this.
Okay, maybe we should back up slightly. Like I'm imagining that we're eventually going to want to do something like this, but insert FFT to do the Fourier transform. So I thought we could just get the graphical part of it set up, and then we can make the inner workings fancier.
So you were imagining like bars, like you would. You're going to just draw the FFT, except in whatever this would be in amplitude space instead of time space, or whatever or it's in time space instead of.
Yeah, so just imagining like we just take a path and we just connect sample 1 to sample 2 to sample 3, and maybe we can plot the left and the right channel in different colors or something, and then we could just see them.
Okay. So you want like my sample plot or sample plot extends stateless widget, and you want to like pass it in some samples. This is me imagining what you're trying to say here.
I hadn't thought about it in that much detail, but this looks great. I had one thought, which is like in the main function of the Flutter, we could read in the file and just shove it in like a global variable, if that makes our life.
Exactly. Well, so we can leave that there for a second. So yeah, we can do that part now, which is, so we didn't actually depend on this in the Flutter section yet, I don't think. Oh, no, never mind. It is part. We don't have to depend on any additional package. We left this in the package. So we just pull in the WAV file, import wave.dart. There may be an assets problem. I expect this file will not be accessible from within the Flutter application. We're going to have to move its location, but that's fine.
We could just use its absolute path.
Does that work?
I don't know.
We might. Or we can just Dart IO our way around it potentially, because we're in the Wild West of desktop. But sure, we can try this. Whatever, what was our thing called? Wave file?
Oh, look.
That's right here. I'll just pull it from the, we just do this.
Yeah. Mm-hmm. We can even go further and just stick the samples in a global variable for now.
And the samples that we care about. Great. Theoretically, if that saves. I see. We need our, what is it called? It's the import Dart :type data or something.
It's like a thing where we make it final. Let's do like 100 of them.
Does that work? File, okay, import Dart IO. Missing concrete implementation. Yeah, that's fine. We haven't gotten to that yet part. All right, great. Sample count isn't used. We don't care.
I'll throw it away for now.
All right. So now in our sample plot,
Oh,
yep, you're going to do bit. Mm-hmm.
Oh, context.
We actually don't need a constructor.
What do I need to do here? So I like want to return like a custom paint. Is that what you're thinking?
I think what you want to do, is a custom paint, custom painter. Is it custom paint or custom painter?
I think the painter is what you pass in. So we need.
You wrote this section of Flutter, not I. So.
Yeah. I don't know if you changed it. Sample.
Oh, we.
And it's custom painter.
That sounds right. Yeah.
I don't actually have the analyzer on my version of this.
Oh, really? You don't see any of this? I guess you can see it on the stream. You need paint and should repaint.
Okay. Do you want
I see. Like it doesn't offer suggestions for you.
Yeah.
Ooh, that's gonna make it hard.
Quick fix. I'm gonna try it. Command dot. That was not doing what do I want.
I also saved at the same time, so it reformatted your file. So let's see. You're gonna want paint. I don't actually know what the signatures look like, so I'm going to open up the custom painter.
Yeah, why don't I let you do this part since you have the actual analyzer going on. Oh, that looks legit.
And you can explain to the internet what we're doing here, because I suspect many people don't know where the heck we are.
Yes, we're sorry. We just jumped to Lightspeed because we're very familiar with Flutter. So generally in Flutter, you build your UI by composing different widgets. Like you can have a button widget or like a spinner widget or whatever. So a very basic kind of widget is a custom paint widget, which says the Flutter doesn't have any idea how to paint this thing. Instead, it's going to just call your code and give you a canvas that you can draw into and tell you how big the canvas is. And then you can draw whatever you want, and then it will fill up the space that the widget takes up.
To be clear, when he uses the word basic here, he doesn't mean that it's like one that you use all the time. It's just it's very like root of the system. The ability to just paint by yourself.
Yeah, it's like fundamental.
So yeah, we don't ever need to repaint our very simple painter.
So I guess our samples go from like plus or minus max int, right? So we want to get like a double is our like I want to convert it to a double between 0 and 1 so I can multiply it by the size. Do you see what I'm saying?
You want to convert our samples. So they're all going to end up being super tiny. You're going to barely be able to see them. But that may be fine because we may just like what's our next phase where we add time to this?
Yes. Samples. So I want like a for loop, right? I'm sort of guessing this stuff from memory. Equals 0. Two. Is that how I have to spell this? It's not about length. Is it size?
Isn't defined for int 16 list.
Oh.
So it is length.
Oh, length in bytes. Properties.
You don't need to do tilde division here, but
It just got mad at me before.
you're still smarting from those squiggles.
Yes, like once burned, twice conscious.
I think I've used tilde division like once a quarter. Go ahead.
So I'm going to do the left path and the right path.
Okay.
And then somehow I want to take like the so I need to know the count. Equals
the sample count.
Yeah, sample count equals divided by 2. So this is still the sample count. And then this is going to become my X step. Which is in double because we're amazing. Divided by a sample count.
Oh, I see. You're trying to decide how to scale your x-axis. Yeah.
So let's see. So my int left sample is samples at 2 times I. Right sample is 1.
Mm-hmm.
And now I need like a gain to figure out how to. So I think maybe we should just set the gain as a constant. I should set the gain as 1.0 for now. But that'll adjust like how it's like the volume.
How high? Yeah.
Like the volume setting on this thing.
Mm-hmm.
So then our x position is our x step 5 times our x step, and our y left is the gain times the left sample. I see. We probably want like a fractional gain. Like, what do we set the gain to? Like 1% times the height.
No, because you need to normalize your samples, right? Divide them by int max, right?
Oh, I see what you're saying. Yeah. So
you want to normalize your samples into 1 to 0, and then your gain.
Yeah, you're totally right. So how do I get int max?
I am not actually sure it is int max, right? It's going to be
int 16 max, right? Like, what's the biggest?
Well, yeah. Here you should add a fix me, right? Because that doesn't handle a variable. Like that only works for this WAV file, but yes.
Right. So I'm just going to copy this comment.
Yeah, this is all going to end up out of this.
Yeah. What about that?
Yeah, that's going to be about right.
So now I need a gain that's like really big.
You just need one, right? I mean, okay, yeah.
Let's go.
Your gain is really like your magnification here. The gain is not maybe the right. I don't think you actually want. So so you need your x range and you need your y range, right? So your y range is like half your height.
Right. Yeah, my y range is half my height. Yeah, I want to map the two, right?
So, and then now what you want to do is you want to take your, what is this? What are you doing here? X left. This is Y left. I think you want to normalize your samples here.
Mm-hmm. Yeah, those should totally be doubles instead of integers. We should totally normalize them here.
So normalize them there. I think it's really interesting. I haven't coded with you in so long, and it is interesting for me to remember how complementary in some ways our coding skills evolved over those many years together.
We've never done this where we've live edited the same file. This is a new experience.
We did live edit a lot of Chromium code sitting 2 feet away from each other, though.
That's true.
But never the same file, yes. Okay, so left sample. And so now you want this is times Y range. And that's it. Like, you don't need a gain. I mean, you could have a gain, but I think you want it to be 1.0.
Oh, so I think if you do this, we'll try this. But I think it's it's going to wiggle very, very tinily around 0.
Oh, correct.
We'll see. So one issue here is you're drawing this. If you think of the
yeah, you need to transform up into the middle.
Yeah, so you just need to like add half, add the Y range again.
Yeah, I don't know if you do this here or if you do it like a transform, but that's fine.
Oh, that's true. You can do it as a transform.
Yeah, it's a little. It doesn't matter.
Yeah, this is good. Okay, so let's do the same thing for the right.
This is where we need to start having functions, right? All of this stuff is just functions.
Yeah, we're writing the ugly code right now.
That's fine.
And then
I'm gonna write the
something I need to do with my left path and line 2.
Can I declare a function inside a function in Dart?
Oh, yeah.
I feel like I should be able to. I don't actually know if I can.
Yeah,
I wrote a little pipe.
Go ahead. I'm mad about this division here. Like it really wants to squiggle.
It's mad because it doesn't have a divisor. Right? Or what did I do? Which division is mad about?
It was mad about the one on line 47.
47.
I put a little squiggle in and made it happy.
Huh. I wonder if there's some warning I've turned on, or maybe Dart's behavior has changed recently.
Yeah, so then you want a function that's like add to path. To path. We path in the path. Path in the normalized sample. And that does.
Oh, it just takes the sample and normalizes it in it.
Oh yeah, really good point. Sample. It's the integer sample.
Sure, because then what you end up wanting to do is you want to do add to path.
Yeah.
Left samples 2 times I.
Yeah.
Right, something like that.
Yeah. So then we put the X in here like this. Yeah.
Well, you don't even, yeah.
Right path. That's 1. So then.
And then the rest of this goes away. Yeah, you just copy it into the.
Yeah, this stuff goes in here somehow. So this
Well, you only need one of them, right?
Yeah, totally.
What's this X? Oh, I see.
I'll get normalize sample. We don't need this one.
So I challenged us on Twitter in the little tweet about the show that I made an hour before we came live, if we could actually draw pixels. And we might actually draw pixels.
Well, hold on. You issued this challenge on Twitter, and you're telling me at the end of the show what the challenge is. This
Well,
is pretty cool.
In fairness, you do follow the show's Twitter account.
I do.
You might be the only follower of the show's Twitter account.
Okay, so we created this wonderful sample plot widget. Should we put it on screen?
Sure. Where do we put it?
We can just make it the body of the scaffold.
Doesn't body have special behavior? Or we got rid of that? Doesn't body have... Whatever. We'll see. All right. Sample plot. And we can get rid of the floating action button. Oh, man. The other thing, when you do a lot of coding, is you sort of get used to your setup. And I don't feel like I'm very acclimated to this setup at home in COVID land. Oh, did I delete it? There we go.
So I realize there's a flaw in our code.
Yeah.
We constructed the path, but we never drew it onto the canvas.
Mm-hmm.
So we have to do
That sounds like a flaw.
This raw path, left path, and we probably need to paint.
You know what? Oh, what color?
Yeah.
And stuff. Yeah. I'm pretty proud of our little drawing code. It may not work at all, but I think it's kind of pretty. It's still, the samples like probably should have been parsed by someone who's not us. Like, this is the wrong function to parse the samples out of the raw byte stream.
Yeah. We can refactor.
Yeah, we don't need. Again, this code is for our amusement.
I'm just doing this entirely from memory here. I don't know if this is.
I mean, you may have worked on this system for several years.
Is the path last, first? No one knows. What does it say? 2 positional arguments found.
Oh, you could also just do a material colors pink or something like that. That's what you want.
Oh,
you don't need to like make up your own here.
Colors is pink. Is that a thing?
Sure, I'm sure. I don't know why it's not. You seem frozen here. Oh. I can do it if I need the analyzer. Pink might be in. Oh no, there it is. Yeah, we want like pink 300.
All right. And what do you want the other one?
It can be green 300 or blue 300, whatever.
Blue 300. Okay.
This is because the Flutter comes with the material, an implementation of the material design spec, which has a whole color library as part of it. And so we're just using that.
That's way better than typing random hex numbers and hoping that they're colors.
Well, and you also got like nicely coordinated colors at the right color weight. Okay.
Oh, I wonder if we just set a width for the path. Let's set a width for the path.
Canvas is not defined for the type paint. Oh, it was mad at us and then it stopped. Oh, it must have been Oh, you mean like a stroke width?
Oh yeah.
It probably defaults to a stroke width 1. But yeah, we should be explicit and send it. Why not? This also isn't going to draw anything again without your gain variable, right? Because it's going to be so tiny and close to the 0.
Okay, well, we can just add in a gain when we see that. Wow, like it takes a long time to come through the tubes. I typed that like a little while ago.
The tubes, they might be clogged. Oh my goodness, you're right.
I've already corrected it to stroke width. All right. It came through the tubes.
It came through the tubes, yes. It came through the tubes and then back the tubes through video. It's faster coming video.
Well, the internet is not a dump truck. I just want to make that clear.
Okay. Some viewer will be amused.
Yeah, these are all like very dated references. I apologize.
Okay. Do we think it drew anything?
Oh, is it
Shall we hot reload?
Oh, we should totally hot reload.
I mean, I've hot reloaded. Let's see. Oops.
Well, we successfully got rid of the floating action button. Do you want to print out the width and height of this thing? Can you?
If we also could do things like we could fill the whole canvas with like a rect or something to prove to ourselves.
Yeah.
And or we could turn on. We could use the Flutter inspector. I don't know why it's not showing anything. I don't know. We may have gotten it confused. You were saying, sorry?
Oh, I just was imagining we were making some very basic mistake.
Oh, I see. So you wanted to like stop this in the debugger and.
I would have done something maybe more graphical, like what you were just suggesting of filling the canvas with a solid color, or.
So let's do it. So if we want to do it first, we'll do like canvas dot fill rect. Is that even a method?
Draw rect, I believe.
It's being quite slow. Rect and paint. Okay. And we want a
.0 ampersand size.
And then we want a paint.
Oh, so ampersand, this is magic. This is a thing that takes a point and a size and gives you back a rect of that size. Oh, it may be offset instead of point. Offset.
Yep, it is. Okay. Let's see if that worked. No dice.
I suspect it's just a 0 by 0 thing. So Flutter has this like widget size negotiation protocol, and sometimes if you're in a funny situation like the body or like something like that, then you'll have a flexible size, and so our thing doesn't have a minimum size. Maybe it just collapsed down to 0.
We could do something really simple.
You can just put it in a size box and say size box.
Yeah.
Yeah. Oh, there's just a thing called expand, which will make it as big as possible. No, size box.expand, I believe is. It's like a naming constructor.
Okay.
Nice. Can we tell if we're like generating exceptions? Where would the exceptions go if we like mess something up really bad?
Aha.
Oh, no such
file.
Oh, so our error was on the very first line of our program. We just put an absolute path if we have that.
Let me see what my absolute path is. Okay, still cannot open file. Operation not permitted. So this is probably a Mac OS thing. There's like Mac OS now has like permissions. You have to like sign up in your info.plist or whatever to be able to do things. And it's possible that we're just reading a random file off the disk, which it doesn't like.
Okay.
So either we could try the assets route, which I don't know if assets are all hooked up for desktop, or we could go to the info plist and turn that on, that like this thing can read from your file system.
So given that we're 7 minutes over, do we want to pause here, or do you want to try to push through and actually get something on screen?
I wonder if there's a compromise in between. I guess we kind of needed to read the file. Yeah. Okay. I think we should probably pause.
We could also time box it. We could say we'll take 3 minutes to try to mess with the plist. And
sure. Okay. Let's say we'll take 10 more minutes to see if we can save this. I'm going to search the internet about. I don't remember what it's called. It's like plist permission. I can actually show you my fair internet what I'm doing here. All right, so if I plist permissions Mac read file. That's not quite right. I just don't remember what they're called. They have a special name. It's like credentials, or do you remember at all what I'm talking about?
I'm very familiar with the concept. I haven't developed for Mac since they invented this.
No, that's not it. Anyone who's done Mac development is just like staring at their screen and screaming.
Shaking their fists. It's the blah, 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 they'll say.
Blah, blah. Another way we could do this is if I open the Xcode, it'll use the word and then I'll refresh my memory. So if I open Mac OS runner.xcode project, code project, this thing. Or alternatively, I expect it's actually just in this. It'll tell me, it'll use the name. I had to do this actually for another. Okay. I think we're going to end up quickly escaping our time box here.
Okay, that's fine. We can also just call it if you like.
Okay, so here we are, entitlements. Aha. So let's turn off our app sandbox.
Oh, you just turn off the whole sandbox.
Turn off the whole sandbox.
I don't want to play in the sandbox. I want to play in the grass. I don't know. What is it, the sandbox?
Okay, so I think we just turned off the sandbox, and now we have to rebuild, like for real. We can't just hot reload to get that change. But that should disable Catalina's, shoving our little app inside a sandbox.
Yeah, I mean, I think sandboxes are really great. I don't think we should be like.
I just for this, for our time boxed. Obviously, someone who worked on security as long as you did.
Sandboxes are near and dear to my heart.
Okay. We're waiting for it to do its building. There we go. It's unfortunate that we can't see into Xcode's brain here, but Xcode is off doing something.
It's spewing lots of exciting text that's convincing you it's worth.
Yeah, which is then getting funneled, into a dev null in this output here.
It's getting filed in the circular buffer.
But theoretically, if this reads, because I think what was happening is we were hot reloading, and then just nothing was happening because we were just hitting an exception.
Mm-hmm. I'm amazed that it drew anything at all. That it didn't just throw an exception.
That's where my brain was going, is why was it drawing anything? I think it's because I had started to delete things, and then when I saved, it sent those changes across. Because it does do little hot reloads. I think by default, the editor is set up to hot reload on save. And so every time we save, it was sending those across as I was deleting stuff out. It's really an impressive amount of time that it takes to build this little application. I think this is one of the reasons why hot reload is powerful.
Because it makes your cycle time super quick.
Yeah, you just don't have to deal with this. I mean, maybe Flutter is doing something wrong in the way that it's holding Xcode here, but if I didn't have hot reload here, I'd be getting up and getting a coffee.
I think it just leads to a different kind of programming. So when you have hot reload, you're much more experimental. You're like, oh, let's try this, let's try that.
Sure.
But I think if you develop a Mac application in Xcode, you're often playing in the interface builder, which is that same sort of feels good, and then only when you're done, you actually run the program.
Yeah, there are different tools to achieve a similar goal. It also may be that changing your entitlements triggers some larger rebuild or something like that. Oh, I see it. I think it never. There we go. Yeah, This is the new one. Somehow it was the old one.
There's something there.
Now, why it draws that, I don't know. We see this.
Oh, I bet we just screwed up our path. I bet our path starts at 0, 0. We have to move to the first one or something.
Yeah.
Anyway, this is legit. Legit. We're seeing the wiggles of the wave.
Yeah. I think we can declare the success. We could fix our one last little bug. But
I think
you see the little wiggles?
We got 2 pixels. We see the pixels. They're wrong, but we got them.
But hey, we successfully read data from a WAV file. We successfully parsed it into the sound information, and we successfully drew it to the screen.
We drew it to the screen. I think this is great. I think next time we'll really get the wave looking beautiful on screen.
Yeah, this is exciting. We got to the graphical part. Anyways, thank you, Adam. This was a lot of fun.
This was a lot of fun.
Anything more to say to the internet before we see you next Thursday?
Stay in your sandboxes, ladies and gentlemen.
Okay. Good night, Adam. Good night, internet.
Good night.